Hello everyone, and welcome to our class video about composite transformations. Our learning goal is that you'll be able to perform a composite transformation on a figure and write the composite mapping. Alright, so let's get started. First, we need to address what is a composite transformation. We've used the word composite before, actually. In this case, a composite transformation combines two or more transformations, and we're going to do them in a specific order. This word composite just means combined together. We've seen it before when we did composite 3D figures, like this one. It's got two 3D shapes combined together, a pyramid and a prism. So we found the composite surface area and we found the composite volume. Now we're going to do composite transformations. Alright, so let's look at an example. Okay, in this first example, we're going to reflect triangle ABC over the x-axis and then translate it down 2 units. So we've got our two transformations. The first transformation is to reflect over the x-axis. Then the second transformation is to translate it down 2 units. Notice the importance of the word then. The word then tells you which transformation is coming first and which one is going to happen second. Alright, well, we would probably need to draw our triangle, so let's plot that. Here's my triangle ABC. Then we need to reflect it over the x-axis. Okay, so to reflect it, I need to figure out, oh, there's the x-axis. I want to point that out. All right, we need to figure out how far away each point is away from the x-axis. So A is 2 away from the x-axis above it, so I need to put it 2 below. C is also 2 above it, so it will go 2 below. B is 4 above the axis, so it will appear 4 below. Okay, so there's my new triangle. I've added the primes, so A prime, B prime, and C prime, to note that that's the new triangle. That's the image. Okay, so let's record the coordinates in the table. A prime is 1, negative 2. B prime is 2, negative 4. And C prime is 3, negative 2. Let's also record the first mapping for that transformation. The mapping for reflecting over the x-axis, in this case, the x's don't change, so we just leave it as x. The y's became negative, so I'll put negative y. They were multiplied by negative 1. So our mapping for reflecting over the x-axis is x, negative y. We covered this in a previous video. If this doesn't make sense to you, you might go back and re-watch the reflections video. Alright, so let's do the second transformation, which is to translate it down 2. So I'll move each point down 2 units. Notice I've added a second prime. So since I've done 2 transformations now, each letter has 2 primes. So we say A double prime, B double prime, and C double prime. Okay, there's my new triangle. The coordinates are 1, negative 4, 2, negative 6, and 3, negative 4. What's the mapping for translating down 2? When we go down 2, notice again that the x did not change, but the y had 2 subtracted from it. Okay, so we have the mapping x and y minus 2. Here's the tricky part. Let's come up with the overall mapping. That is, the mapping that applies all the way from the start to the finish. We're going to take mapping number 1, and then we're going to do mapping number 2 to it. Okay, now that will take some explanation here. Okay, so what is mapping number 2 telling us to do? It's telling us to take y and subtract 2 from it. Okay, so I'm going to take the mapping that's in mapping number 1. There's mapping number 1. And then I'm going to do what mapping number 2 said. I'm going to subtract 2 from the y. So the y coordinate here is negative y. and I subtract 2 from it, I would get negative y minus 2. You can test this by applying it to any individual coordinate. Like, for example, I could take the 2 here, do negative 2, because I'm plugging in here, subtract 2 from it, and I would get negative 4, which is right here. You could do that for any of the other ones, and it would also work. That's a way to check your answer to see if you got it right. All right, so now let's go on to the second example. In this one, we're going to translate the same triangle ABC down to units, then reflect it over the x-axis. This is exactly what we did in the previous one, except we're going to do the transformations in the opposite order. We're going to first translate down, then reflect it. Let's see if that makes a difference. So, here's my triangle. I need to translate it 2 down, so let's move it 2 down. All right, there we go. There's the new triangle, A prime, B prime, C prime. The coordinates now are 1, 0, 2, 2, and 3, 0. The mapping, like we said in the previous question, is x comma y minus 2. Okay, now we need to reflect it over the x-axis. Excuse me. So here's the x-axis. Notice that A and C are not going to move. So A double prime and C double prime are in the same location. But I need to reflect B, so since it's 2 above the axis, now I'll move it 2 below. There's my double prime triangle. The coordinates are 1, 0, 2, negative 2, and 3, 0. Just like before, the mapping for that transformation is x comma negative y because the y has changed sign. Let's come up with the overall mapping for this transformation then. Once again, we're going to take mapping number 1 and do mapping number 2 to it. What is mapping number 2 telling us to do? It's telling us to multiply y by negative 1. That's how we changed the sign. That's how we went from 2, positive 2 in B prime, to negative 2 in B double prime. Okay, so I'm going to start with my overall mapping, or the mapping number 1. Now I need to take the y coordinate and multiply by negative 1. Now notice, I have to multiply the entire y coordinate by negative 1. That's why I added the extra parentheses. So in order to figure out the overall mapping, I need to distribute that negative sign. When I do that, that's going to become, well, x is still x, okay. Then we'll have negative y, and negative negative 2 would be plus 2. So that my mapping is x comma negative y plus 2. So my question then is, does it matter what order I do the transformations in? Just by looking at the previous examples, I hope you see that the answer is a big yes. In example 1, our mapping was x comma negative y minus 2. In example 2, the mapping was x comma negative y plus 2. So changing the order made a big difference in the mapping. Let's look at a couple more examples to see how this works. We're going to write the mapping for these two, okay? And the transformations are performed in the opposite order. Okay, we're going to do a horizontal stretch, which would be multiplying the x coordinates by 2, and the y stays the same. We're going to do a horizontal stretch with a scale factor of 2, followed by a translation 4 units right. The mapping for that one is x plus 4, and y stays the same. Notice the phrase followed by. Once again, that tells us which transformation happens first. The one after followed by happens second, and the horizontal stretch happened first. Okay, so we're going to take mapping number 2 and do it to the first mapping. Mapping number 2 is telling us to add 4 to the x coordinate. So I'm going to do that to the 2x. So I'll take the 2x and add 4 to it. Nothing happened to y. So there's my mapping for that transformation. In the next one, we're going to do the translation first, followed by the horizontal stretch. The translation happens first, and the horizontal stretch happens second. So I'm going to take the second mapping, which is to multiply x by 2, and do that to the first mapping. So I'm going to multiply the entire x coordinate by 2. So I'm going to multiply the entire x plus 4 times 2, because that's what the mapping said to do. Distributing that 2 would lead me to conclude that the mapping is 2x plus 8, comma y. Notice again that changing the order made a big difference. So the main thing I need to point out, or I want you guys to get, is that order matters. Alright, we'll keep looking at this. I know this is tough, so we'll go through some more examples in class. Alright, see you guys later.